trig values. So you can obviously type sine, cos and tan of any angle into your calculator and you'll get the answer. However, for certain values, we can actually work them out by using a bit of logic. We're going to go through how to work out 0, 30, 60 and 90 degrees, and we're going to work out sine, cos and tan for all of those. Okay, let's start off with 0, and let's first start by drawing a unit circle. Okay, so if theta is 0, that means I'm going to draw this in blue. Our line to the circumference is right here. Okay, now what is the adjacent length? It's just going to be 1, and what is the height? The height is going to be 0. Okay, 0 height. This means that we always know that the adjacent is cos theta and the height is sine theta. So sine theta is 0 and cos theta is 1. So let's fill that in. Sine 0 is 0 because the height is just 0, and cos 0 is right degrees, and cos 0 is 1 because the length along the x is just 1. Okay, now what about tan? So I'm going from here and I'm extending to the point where the extended radius meets the vertical. You notice that it already touches the extended radius, like it already touches here. That means the height is just 0. And also from the previous video, we know that tan theta is equal to sine theta over cos theta, because tan theta just represents the gradient. And if you put the values in, you get 0 over 1, which is just 0, which is why tan 0 is 0. Now, what about when we're doing sine theta? Sorry, sine 30. So select there, 30. Okay, so I'm trying to work out the height and the length for sine and cos. Let me draw over here, because there's a neat trick that we can use. This is 30 degrees, this is a right angle, this is 1. Okay, and now this side length represents sine 30, and this represents cos 30. Okay, I'm just going to rub out the cos 30 part to show you something. So we're going to first work out sine 30. Now, if this angle right here is 30 degrees, that means this angle is 60 degrees. Now, watch what would happen if I reflect this triangle. It forms, I'm going to draw this in blue, a bigger triangle. But specifically, this angle would still be 60, and this angle would double, so this is also 30. So this entire thing is 60. This is an equilateral triangle. That means that this side is 1, this side is 1, and most importantly, this side is 1. Now, the sine 30 is just half of this entire length. Because remember, sine 30 is just this part. Therefore, sine 30 is equal to 1 over 2. So sine 30 is just the half. Sine 30, 1 over 2. Okay. Now, you can use basic Pythagoras to work out cos 30. So 1 squared minus a half squared is equal to cos squared 30. So this is 1 minus 1 over 4 is equal to 3 over 4. And then square root this, you get root 3 over 2. Okay, so cos 30 is root 3 over 2. Root 3 over 2. Now again, remember, tan 30 is just sine 30 over cos 30. 30 over cos 30. So this is equal to 1 over 2 over root 3 over 2. You times top and bottom by 2. You get 1 over root 3. And if you rationalize the denominator, you get root 3 over 3. So tan 30 is just root 3 over 3. Okay. Now let's move on to 60. And 60 would be about there. Okay. I'm going to repeat the same thing. Do that. This is 1. This is 60. Now remember, the opposite represents sine 60. And the adjacent represents cos 60. Okay. Now I'm going to remove sine 60 for now, because we're going to start off with cos 60. If this angle is 60 degrees, and this angle is 30 degrees, and again, notice that if I reflect it, but along the opposite, I again get the right angle triangle, sorry, the equilateral triangle, because this would be 60, and this would be 30, so this entire thing is 60. So this is an equilateral triangle, that means this side length is 1, and so is this side length. Now cos 60 is just half of this entire side length, so cos 60 is 1 over 2. Cos 60, 1 over 2. Now, if you do the Pythagoras, 1 minus 1 over 2 squared is equal to sine squared 60, because 1 over 2 squared plus sine 60 squared equals 1. And I'm just rearranging that to get this. You get 1 minus 1 over 4, which is 3 over 4, and then square root 3 over 4, you get root 3 over 2. Now notice it's just these two reversed, which is actually important when we go on to find further trig identities. Now find tan 60 by doing the division. Tan 60 is equal to root 3 over 2 over 1 over 2 times top and bottom by 2, and you get root 3 over 1, which is root 3. Root 3. Now, when we're finding sine, cos, and tan of 90, it's just a straight up. This is thing. Now, what is the height? Would represent sine theta, and we know that the height is just 1. So sine 90 is just 1. Now cos theta is just the width, aka the length along the x, and that is just going to be 0. And now if you do sine over cos, you get tan. But notice that if you do tan is equal to sine over cos, that would be 1 over 0. And you can't divide by 0, so this would just be undefined. 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 Now, this is also undefined, is because remember from the previous video, if I show what tan represents, tan will represent the height at which the radius would meet it. Notice these two lines are parallel, so they would never meet. So no matter how long I extend this line, it would never meet the extended radius. For example, how like 60 or 30 would. Because no matter how much I extend this and this by, they would never meet. Therefore, it's just undefined. And also, Remember, tan is just the gradient, and the gradient of a vertical line is just undefined. However, the gradient of a flat line is 0. This is why we've got that there. Now notice how the sine and cos values just reverse as we go along. First it's 0, half, root 3 over 2, 1. And cos is just the opposite. 1, root 3 over 2, half, 0. That's important, and I'll explain why in future videos. Thank you very much for watching.